Hi everyone, today I'm excited to present our work IrokoBench, a new benchmark for African languages in the age of large language models. I'm David Adelani, an assistant professor at McGill University, and I'm happy to have co-authored this paper with several authors listed on the slides. The motivation of our work starts with thinking about existing large-scale multilingual evaluations, such as megaverse, which typically focus on a few African languages. And if you look at the benchmarks they cover, they often cover non-challenging tasks in the LLM era, such as token classification, sentiment classification, text generation task. However, for high resource languages, in the LLM era, they typically evaluate on very knowledge-intensive tasks and reasoning tasks such as mathematics and code reasoning. So if you look at a benchmark that was produced by Cloud3 when it was launched, you'll find out that they typically do more difficult tasks. So having looked at existing benchmark and looking at the tasks they work on, so we decided to cover the following task: natural language inference, which still kind of survived, for example, for the Bloom model, and then we also cover like some other knowledge intensive tasks like MMLU and multilingual MGSM, which math reasoning, which we try to extend to several African languages. So our contributions are the following. We introduced IrokoBench, a human translated benchmark that covers 17 African languages with various degrees of low resourceness. And also we cover tasks such as MMLU, math reasoning, and natural language inference tasks. Then we evaluated 10 open models and 6 proprietary models, and we showed that there's still a large gap in performance between English and African languages. And also we found the large gap to even to be more for open models compared to proprietary models when evaluating on low resource languages. And then we found out that languages with the lowest performance, such as Ewe, Twi, and Wolof, are also the languages with the smallest amount of monolingual data on the web, as covered by the MATLAB tokens. So our benchmark, so in this slide I provide like an example for each of the tasks that we cover. For AfriXNLI, you have a question which is like a mathematics word problem where you give an example and then the student is supposed to give an answer. And also we have more factual questions like MMLU, which is trying to know, which is based on the subject global facts. But there are also many other categories in MMLU covering different subjects. And XNLI has 2 sentences, and we are supposed to say if these 2 sentences entail each other or has a neutral connection or contradict each other. And our benchmark is based on a popular tree, hardwood in West Africa, also called Iroko, and can be used to make bench, which gives us IrokoBench. Our dataset construction is very simple. We took subsets of the instances in existing dataset, and then we perform human translation to various African languages. So for the MMLU, we only selected like 5 subjects that are mostly international and do not have a lot of cultural bias, and that are also easy to translate. So this is our criteria for selecting the subject. Second one, we actually collected data for all the domains of XNLI, but we only selected like fewer samples, very similar to what has been done for America's NLI when it was created. We only translated like 1,000 samples. And lastly, for MGSM, the number of samples are small, 250, we translated everything. So in terms of the models we evaluated some proprietary models like Anthropic, Cloud Opus, Gemini 1.5 Pro, and also different variants of the OpenAI models like the GPT-4. For the open models, we evaluated like encoder-decoder models like Kaya 101 and very popular models like Llama 3, Gemma 227B, and also Llama X, which is an adaptation of Llama 3 8 billion, including we also evaluated like Courier, Command Haro, and Bloom's 7B. For the evaluation setting, we perform covers three settings. Number one, which is target language zero-shot evaluation, and we also perform translate test to English and followed by zero-shot evaluation. Lastly, we did some few shot evaluation, like 5 shots for MMAU and NLI, and 8 shots for math reasoning. But we'll skip that just because of the shortness of time, and you can find the rest in the paper. So we evaluated on 5 different prompts, but we only show results for the best prompt. So our first result, which is our first key result, is that there's still a large gap between proprietary models like GPT-4 and open models like Gemma 2. This is an evaluation across an average or overall result across all tasks. So when we apply translate tests, you find out that for open models such as Haya and Llama 3 and Gemma, actually translate test does help them to boost the performance of the overall result. But when we compare the translated results with that of English, you find that there's still a very big gap between the high resource languages like English. So the second result, when we break down the result by task, one thing you can see clearly is that math reasoning often has the lowest performance across all models, especially for the open models, followed by the knowledge-intensive task. So these tasks are very difficult. We find IA doing very well for NLI, but apart from that, it did much worse for other tasks. So for the math reasoning, we actually find out that the performance scales with the amount of data on the web, where you have English reaching the performance of over 80 for most of the languages, and Swahili over 70. And Yoruba, you find out that for most open models, the performance is really terrible, while only GPT-4 62. But in general, GPT-4 all result also scales by the number of data on the web. So so we also have a result. We showed the result of MMAU, and we saw that the result also varies across tasks. Interestingly, we find that the math reasoning, actually the elementary maths subject actually has the best performance, even for low resource languages like Wolof, which is quite interesting. Probably because many models now are being post-trained a lot on maths, and this also transfers very well to low resource languages. Why tasks like global fat, which is very knowledge intensive, seems to struggle a lot, especially for low resource languages. Finally, we compare the results of LLMs to cross-lingual transfer on the NLI task, and we find out that GPT-4o is now very competitive to cross-lingual transfer, unlike before. But also, this also depends on the multilingual encoder you use. If you use a worse multilingual encoder, it's often better to use GPT-4o. But if you use a stronger one, there's still some slight better performance using AfriXNLI, which has been adapted for African languages, than using GPT-4o on average. Finally, since we evaluated on 5 different prompts, we find out that the evaluation is very sensitive to prompts. For example, for AfriXNLI, we find out that prompt 2 is preferred by some open models like Haya and Gemma, while for prompt 3 that is more detailed is preferred with proprietary models like GPT-4o. In conclusion, so in this paper we introduce IrokoBench, a new benchmark that extends beyond classification tasks to more knowledge-intensive and reasoning tasks, such as MMAU and math reasoning. Our evaluation shows a large gap in performance between high-resource languages such as English or French and African languages. And the gap in performance is even much wider for open models such as Gemma 227 billion compared to proprietary models like GPT-4o. Thank you. If you have questions, come to my talk.